All right, let's dive in. Today, we're going to pull back the curtain on the secret language of the internet. It's the invisible code that lets all your favorite apps talk to each other every single second of the day.
You know, it all kind of feels like magic, doesn't it? You tap a button, you check the weather, you post a photo, and boom, it just works. But it's not magic. What's really happening is a constant, silent conversation between all those applications.
So here's the core problem you got to understand. Most apps are basically their own little islands. I mean, your weather app doesn't have its own satellite, right? It's an island of code, and to get any information from the outside world, it desperately needs a bridge.
And that bridge, well, it has a name. It's the API, which stands for Application Programming Interface. Think of it as the universal connector that lets all those separate little islands finally talk to each other.
This right here is the heart of it all. One application sends out a very structured request, that's the API call, to a specific address on another system. It's basically knocking on the door and asking, hey, can I please have some data? Or can I change something over here?
So you see, an API isn't the data itself. It's not the database. It's the rulebook. It's the official contract that says, if you ask for information this specific way, I promise to give you a response that specific way. It's the shared language that allows two completely different programs to understand each other perfectly.
Okay, I know this sounds a bit abstract, so let's use a real-world example that makes it super clear: an ATM. When you request cash, that's your API call. The ATM machine itself acts as the API, the interface that securely contacts the bank's server. The bank then validates your request and sends back a response, hopefully approved. And finally, the ATM acts on that response and gives you your money. It's the perfect metaphor for this whole digital handshake.
So what's actually inside one of these requests? I mean, what does it look like under the hood? It's not just a vague question, it's a highly structured message. Let's break it down.
Every single request is like sending a very specific kind of package. First, you have the method, that's the verb, like get or post, telling the server what you want to do. Second, the endpoint URL, which is the specific address you're sending it to. Third, you have headers, which are like the little notes on the shipping label, maybe authenticating who you are. And finally, sometimes you have a body, the actual stuff inside the package.
And these right here are the four most common verbs on the internet. A GET request is basically asking to read something. A POST is when you want to create something totally new. PUT is for updating something that's already there. And, well, delete, I think you can guess what that one does. So once the server gets this request, it does its job, and then it sends a response back. And this response always includes a status code. It's a simple, universal signal that tells you exactly what happened. These codes are grouped into really simple categories. If you see a code in the 200s, like 200 OK, that means everything worked perfectly. Great. If you get a 400-level code, like the infamous 404 not found, that means you, the person making the request, made a mistake. And if you get a 500-level error, that means something broke on the server's end.
So the server has the data and it's ready to send it back. But for this to work with any app in the world, the data has to be in a format that anyone can understand. It needs a universal translator. And that's where our second hero comes in, JSON.
JSON stands for JavaScript Object Notation. Now, the absolute genius of JSON is that it's super easy for computers to understand, but just as important, it's also easy for us, for humans, to just look at and read. It's all built around this simple idea of name-value pairs. And here's the wild part. All the complex data in the entire world is described using just these 6 basic building blocks. You've got simple text called strings, numbers, true or false values, lists called arrays, and the main structure, which is an object of key-value pairs. That's it. Everything is built from these simple little parts. But, and this is a big but, that beautiful simplicity comes at a cost. The rules, the syntax are incredibly strict. A single misplaced comma, the wrong kind of quote, and the whole thing just breaks. The system will flat out reject it. And this precision is absolutely non-negotiable. Let's look at one of the most common errors, the trailing comma. In a lot of programming languages, an extra comma at the end of a list is no big deal. But in JSON, nope, it's a fatal error. Here's another classic mistake that gets people all the time, using single quotes. You might think, what's the difference? Well, to a JSON parser, the difference is everything. The rule is simple and absolute. Everything must be wrapped in double quotes, period. This strictness even applies to the keys, the property names on the left side. They also have to be quoted strings. Forgetting to quote that key will make the whole message invalid. And this isn't just nitpicking. It's the very thing that makes JSON work everywhere, reliably.
So why? Why be so strict? Why not even allow something simple like comments to explain the data? This quote from JSON's creator, Douglas Crockford, explains everything. He intentionally left comments out to force JSON to be nothing but pure data. He knew that if he allowed them, different systems would start using them in different ways, and that would have shattered the whole point: universal compatibility.
Okay, so let's zoom back out. When you take these two powerhouses, APIs, the universal connector, and JSON, the universal language, and you put them together, you literally get the engine that runs the entire modern internet. Just think about your day. Every time you check the weather, your app is making a GET request to an API and getting back JSON with the temperature. When you post on social media, your phone is sending a post request. When you buy something, the website uses an API to talk to a payment service like Stripe. Even the latest AI chatbots, they're often powered by APIs, letting any app in the world tap into their power.
And this is really what it all boils down to. This constant, invisible chatter of API requests and JSON responses isn't just some minor technical detail. It is the fundamental process that makes our entire interconnected digital world possible.
So our whole digital life is built on these invisible threads, woven together by these simple standards. It's an incredibly robust system, but it also makes you think about how much we depend on these connections. And it leaves you with a question, right? What happens when just one of those tiny threads breaks?